everyone, I am Hani Michelle F. Intrepito and I'm gonna discuss to you the sewer pipes and flow in sewers. So first, what is sewer pipe? A sewer pipe is a conduit for the elimination of waste materials. It is a large pipe, usually underground, that is used for carrying wastewater and human waste away from buildings to a place where they can be safely got rid of. So this is an example of what a sewer pipe looks like. So there are three types of pipe materials: the metal, non-metal, and clad or composite. In the metal, there are two types, the ferrous and the non-ferrous metal. So we have an example of the ferrous metal. It is carbon steel pipe. Its characteristic includes strength, wall thickness, corrosion resistance, and temperature and pressure limitations. The next is copper. Copper is an example of the non-ferrous metal. Copper tubing is used for hot and cold water, while PVC has replaced much of copper use due to PVC's lower cost. Copper is still an excellent pipe for potable water. Next is chlorinated polyvinyl chloride or CPVC. It is a non-metal pipe. This type of non-corrosive pipe is used for hot and cold up to 180 degree Fahrenheit. It is durable and easy to use. So the difference between CPVC and PVC is that CPVC is altered by a free radical chlorination reaction that effectively increases the chlorine content of the material. So CPVC has more chlorine than PVC. Next is flow in sewers. The flow in a sewer is usually turbulent and changes with respect to time and location in the sewer pipe, hydraulically referred to as unsteady and non-uniform flow. The flow in a sewer can be divided into three regions: the entrance, the pipe flow, and the exit. So, in pipes, we have the formula of the head loss. First, the formula is from Hazen-Bousville equation, where head loss is equal to 128 mu, or the absolute viscosity, multiplied by the length multiplied by discharge over 2 times density times gravity times diameter raised to the fourth power. So next is the Darcy-Weisbach formula, where head loss is equal to 0.0826 multiplied by the friction factor multiplied by the length multiplied by the discharge squared all over diameter raised to the power of 5. And the next is the Manning's formula, where head loss is equal to 10.29 n squared, where n is the coefficient of expansion multiplied by the length multiplied by the discharge squared all over diameter raised to 16 over 3. Next is the Hazen-Welling formula, where head loss is equal to 10.67 multiplied by length multiplied by discharge raised to the power of 1.85 all over the Hazen's coefficient raised to 1.85 multiplied by the diameter raised to 4.86.